Beneath our feet lie forces powerful enough to reshape the world. Supervolcanoes, vast calderas only visible from space. An eruption from one would be a planetary event, altering climates and threatening life as we know it. Scientists vigilantly monitor these sleeping giants, searching for the faintest signs of unrest. Join me as we explore 7 of the world's most significant supervolcanoes, uncovering the science and history behind these hidden titans. In Yellowstone National Park, geysers and hot springs hint at the immense supervolcano below. The park sits atop a caldera formed by eruptions 1,000 times more powerful than Mount St. Helens. Yellowstone's last supereruption, 640,000 years ago, blanketed much of North America in ash. Today, a network of seismometers and GPS stations tracks every tremor and subtle ground shift. Scientists use seismic tomography to map the complex sponge-like magma chamber beneath the park. Old Faithful and other hydrothermal features are direct links to this underground heat. Changes in gas emissions and ground deformation are closely watched for warning signs. Life here thrives in extreme conditions. Extremophiles color the hot springs and bison roam the caldera floor. Yellowstone is both a natural wonder and a living laboratory, providing crucial data for understanding supervolcanoes. While a super-eruption is unlikely in our lifetimes, the consequences would be global. Continuous monitoring refines our models and deepens our understanding of these colossal forces. Yellowstone's dual nature as both creator and destroyer reminds us of the planet's power. The world's attention remains fixed on this sleeping giant. In Italy's Bay of Naples, the Campi Flegrei caldera lies hidden beneath city streets and the sea. This densely populated region experiences bradyseism, ground rising and falling as magma and fluids shift below. Recent decades have seen increased unrest. Rapid uplift and earthquake swarms unsettle 500,000 residents. Scientists at the Vesuvius Observatory monitor every tremor and gas emission, searching for signs of fresh magma intrusion. The last major eruption, in 1538, created Monte Nuovo in days. But the Campanian ignimbrite eruption 39,000 years ago was far more devastating. That ancient event plunged Europe into volcanic winter and may have hastened the Neanderthals' decline. Today, evacuation plans are constantly updated, and the local population lives with a deep awareness of the volcano's power. The challenge is distinguishing routine unrest from a true prelude to eruption. Campi Flegrei's history and ongoing activity make it a focal point for global volcanic research. The stakes are high in this restless landscape. Scientists strive to interpret the signals, knowing the next phase could change everything. Living here means adapting to uncertainty, with resilience forged over millennia. The world watches, hoping for more time before the next awakening. Lake Taupo in New Zealand fills a caldera born of cataclysmic eruptions. The Hatape eruption, 1,800 years ago, was the most violent in 5,000 years, devastating vast areas and coloring skies as far as Rome and China. The Orowanui eruption, 26,500 years ago, was a true super-eruption, reshaping the North Island and spreading ash to Antarctica. Today, the Taupo volcanic zone remains highly active, with constant ground movement and geothermal activity. GNS Science's GeoNet project monitors earthquakes and ground deformation, raising alert levels when unrest increases. Geothermal fields around the lake power much of New Zealand, harnessing the volcano's energy. But the ever-present heat is a reminder of the destructive potential below. Scientists study past deposits to understand the dynamics of explosive rhyolitic eruptions. Each layer of ash tells a story of destruction and renewal. Taupo is a natural laboratory, offering insights into forecasting future hazards. The volcano's history is a cycle of violence and rebirth, shaping both land and life. Living with Taupo means respecting its power and learning from its past. The lake's tranquil surface hides a restless heart. On Sumatra, Lake Toba fills a caldera left by the largest eruption in 2.5 million years. The Toba supereruption 74,000 years ago ejected nearly 3,000 cubic kilometers of ash, triggering a volcanic winter and a global temperature drop. The Toba catastrophe theory suggests this event nearly drove humanity to extinction, shaping our evolution and migration. Today, Samosir Island rises in the lake, a resurgent dome signaling the magmatic system is still active. Scientists monitor uplift, gas emissions, and seismic activity, knowing any unrest here is a global concern. The focus is on understanding the slow recharge of magma beneath the caldera. Local communities live atop this ancient scar, their culture intertwined with the lake's legacy. Toba's story is one of devastation and survival, a reminder of nature's power to shape life. The caldera is quiet now, but its history demands vigilance. Monitoring efforts are international, reflecting the eruption's worldwide impact. Toba stands as a testament to both the fragility and resilience of humanity. The lessons learned here inform our understanding of supervolcanoes everywhere. Life flourishes again, but the memory of catastrophe endures. In Japan's Kagoshima Bay, the Aira caldera hides beneath the water, with Sakurajima volcano rising from its depths. Sakurajima, one of the world's most active volcanoes, is the modern vent for the caldera's vast magma system. The city of Kagoshima, home to over 600,000, lives in the volcano's shadow. Children wear hard hats, and ash is a daily reality. The Sakurajima Volcano Research Center monitors every tremor, plume, and ground shift. The 1914 eruption connected Sakurajima to the mainland, a reminder of the volcano's power to reshape the land. Scientists are concerned not just with daily explosions, but with the possibility of a much larger caldera-forming event. Data shows the magma chamber is recharging faster than Sakurajima can release it. The constant activity provides a unique window into supervolcanic processes. By studying frequent eruptions, researchers learn about magma composition and underground plumbing. The relationship between city and volcano is one of preparedness and respect. Sakurajima is a natural laboratory for understanding the buildup to super eruptions. The threat is ever present, but so is the opportunity for scientific discovery. Life here adapts to the rhythm of the fire within the bay. In eastern California, the Long Valley caldera is a vast depression formed by a colossal eruption 760,000 years ago. Modern unrest began in 1980 with powerful earthquakes and rapid ground uplift, prompting the creation of the Long Valley Observatory. The resurgent dome at the caldera's center has risen nearly a meter since the late 1970s, signaling magma accumulation. Earthquake swarms and carbon dioxide emissions continue, killing trees and revealing the system's activity. Scientists use seismic imaging, gravity, and electrical measurements to map the magma chamber and track changes. The challenge is interpreting decades of unrest. Will it lead to eruption, or is it a new equilibrium? The proximity of Mammoth Lakes and Bishop adds urgency to monitoring efforts. Understanding Long Valley's behavior is vital for public safety. The caldera's signals are complex, and answers remain elusive. Ongoing research is a public service, not just academic curiosity. The landscape's beauty belies the power beneath. Communities here live with both risk and wonder. The story of Long Valley is still unfolding. In El Salvador, Lake Ilopango fills a caldera with a violent past. The Tierra Blanca Joven eruption in 431 AD blanketed the region in ash, disrupting Mayan civilization and forcing mass migration. Ash from the eruption reached as far as Greenland, showing its global impact. The caldera remains active, with lava domes in the lake's center formed in later eruptions. Ilopango's proximity to San Salvador puts over 1.7 million people at risk. Even a small eruption today would have catastrophic consequences. Scientists monitor tremors, ground deformation, and water chemistry for warning signs. Much of the volcano is hidden beneath water, complicating observation. Ilopango is a reminder that supervolcanoes threaten every continent, often near major cities. Understanding their history is key to preparing for the future. The lessons of Ilopango echo across time and geography. Our journey reveals a world shaped by immense restless power, supervolcanoes that have guided the course of life. Scientists' constant vigilance is our best defense against these unpredictable giants. By listening to the Earth's whispers, we gain precious time to prepare. This knowledge calls for respect, not fear, and for continued scientific inquiry. As cities grow in active regions, understanding these risks is more critical than ever. The more we learn, the better we can live in harmony with our planet's powerful rhythms.